Okay, so now we want to look at having specific solutions, and either those solutions are acidic, and the way you know you have an acid is that it's going to have a hydrogen that will dissociate off, and so most likely that hydrogen is the first part of your formula, or you have a base, and the base has the ability to make hydroxide. So the first we're going to look at is today we're going to look at just strong acid and strong base problems. And we're going to start with the acids. Now, not only do you have to recognize that it's an acid because it has that ionizable hydrogen in the front, but you have to be able to recognize it's a strong acid. So again, you need to memorize the list of strong acids that's on the backside of your periodic table. And so the problem we're going to look at is number 60, letter A. That's in the chapter 14, end of chapter problems. And they give me that I have nitric acid. So again, there's that hydrogen in front, and it's on my strong acid list. And we know from our discussion earlier that strong acids completely dissociate to give me a hydrogen ion and an anion, which in this case is going to be nitrate. And so in 60A, it tells me that the concentration of my acid is 2.0 times 10 to the negative second molar. And if I look, my acid and my hydrogen ion or hydronium are in a 1-to-1 ratio. So this means that the concentration of the hydrogen ion would also be 2 times 10 to the negative second molar. Right. So the pH is the negative log of the hydrogen ion. So we're going to take the negative log of 2 times 10 to the negative second. And you're going to plug this in your calculator just like it looks. So you're going to hit the negative sign, then the log button, and then 2 times 10 to the negative second. So if you want to pause the video while you chug out an answer. All right. And then so we see that this has 2 sig figs in my concentration. So this means my pH should have 2 decimal places. So you should have 1.70 as your pH. All right, the second type of problem we want to look at is bases. And we're just, for now, going to focus on strong bases. Okay. And so here's what I want us to do. We are going to calculate the hydroxide ion concentration, the hydronium ion concentration, the pH and pOH, and what we have is a 0.0040 molar solution of calcium hydroxide. Okay. So again, bases have a hydroxide ion, and we know this is a strong base because the metal attached to it either comes from group 1 or group 2. In this case, calcium comes from group 2. So we're going to write our dissociation equation first. So this breaks apart to give me a calcium ion, and it gives me 2 hydroxide ions. And so the concentration of calcium is 0.0040 moles per liter. And we're going to need to use a mole ratio. So we're going to go from moles of calcium hydroxide to moles of hydroxide. And I can see that there's 1 mole of calcium hydroxide and 2 moles of hydroxide ion. And so this tells me the concentration of hydroxide is 0.0080 molar. Okay. All right, then from here we can use Kw to find the hydrogen ion. So we have 1 times 10 to the negative 14th is equal to the hydrogen ion times hydroxide, which is 0.0080 molar. We're going to solve for the hydrogen ion. Okay, so again, you can pause the video and tug out an answer and hit resume when you're ready. All right, and then when I look at both Kw and the hydroxide, both have 2 sig figs, so your hydrogen ion concentration should have 2. We're going to get 1.3 times 10 to the negative 12th molar. Okay. All right, so let's find, now that I have hydrogen, let's find my pH. So we're going to take the negative log of 1.3 times 10 to the negative 12th molar. And my concentration has 2 sig figs, so my pH should have 2 decimal places. So once you plug out an answer, you should get 11.89. And if I add the pH to the pOH, this would equal 14. And so both my 14 and my 11.89 have 2 decimal places. So your pOH should have 2, you get 2.11 at your pOH. So now you should be able to solve problems that are related to strong acids and strong bases.